So good afternoon. My name is Ravi. Good afternoon. My name is Ravi. I'm from Precision, and I see that there's a lot more energy. Normally, after lunch, it tends to be a sleepy session, but today, I think lunch has given us a lot of incentive to talk about nice things. And unfortunately, I come at a stage where I think all of you have the questions for me, because you are asking the questions to Mr. Raj, but I think I'm going to get caught in the same thing. I'll try to do my best, but there are lots of ifs and buts, so we'll go through that. So I'll not bore you with too much of Precision, just basically 25-year-old company, about 2,000, 3,000 employees all over India. And why am I here? I'm here because of the need to develop an indigenous hardware for crypto tokens. So all the crypto tokens that we are using today comes from border sharing countries. You know what that means. We are a company who's developing a token, hardware token, everything inbuilt with no border sharing components. Now, just a minute. Yeah, good. Now, before I go into the hardware itself, I think most of you may be aware of this, but just to give a context to the whole thing, let me talk about, I think today in the morning, Mr. Ramakrishnan talked about the act. There is an act, and there are guidelines. Now, the guideline is not just everything should be FIPS 140-2 compliant, but the guideline goes into a lot of details. So what you see on the right-hand side are about 17 different aspects of a token, a security token to be certified. These are the CCA guidelines which govern how a token is certified. So a lot of questions that you had asked, how do I certify a phone, will also apply to this category. Now, as I said, the guidelines are available there. The security requirements. So basically, how does one define a guideline? There's a list of requirements that CCA has been kind enough to document. It's all documented in the CCA procedures. And the central theme of that is FIPS 140-2. 140-2 is not adequate. If I put a module called 140-2, it doesn't automatically make that Indian government CCA approved token. We have to do a lot more things other than that. And this guideline, if you go into details of each one of this, some of these points will say this is equivalent to FIPS 140-2, and hence complying to FIPS 140-2 is adequate. In some other cases, let's say key output. For key output, they would say that if it is FIPS 140-2 certified, it's not enough. You have to show evidence that you have configured the chip in such a way that your private key is not exported. It's not just enough to say, I have a module which is FIPS 140-2, I'm certified. No. You have to go to the auditors and demonstrate and prove to them that it is not, you have configured the system in such a way that private key cannot be exported. So in each one of these clauses, in some clauses it says, if you comply to 140-2, you're okay, there's nothing more needs to be done. In certain clauses, there are additional testings that CCA has stipulated that we should go through to be certified. Now, what I think I'll request a transparent set of tokens. Pass the whole block, pass the whole thing as it is. Okay. So far you've been hearing mostly software part. So just to give you a touch and feel of what is happening, I've sent around a set of keys. Not just the token that you have seen, but the token broken into pieces and individual components in that, and just for you to get a feel for what it is all about. Now, what we are in the business of is doing is, we are building this token, which has at its heart FIPS 140-2 compliant thing, and naturally, according to the CCA guidelines, we will we'll have to document how we are implementing all the requirements of the CCA. There will be an independent certain empaneled auditor who will walk through all these requirements and then certify the token. So obviously no components from border sharing countries. The FIPS 140-2, the TPM module, many of you may have heard of TPM. TPM has been around for many, many years. It's at the heart of security in most of your laptops and computers everywhere. Now what we have done is we have successfully moved that TPM module, which is FIPS certified, when you're talking about certification, is it only the hardware, software? You have read everything. Basically, that module contains a firmware. The hardware piece contains firmware. The firmware plus the hardware chip is what is FIPS certified. So everything around the chip is never FIPS certified. Let us say you use a PKCS11 module. The PKCS11 module is just an interface to say how you talk to the token. It is not FIPS certified. The PKCS11 is a standard which says if you want to create a private key, this is the way you have to do it. It is not FIPS certified. It is the boundary is the chip. The firmware within the chip and the libraries that they have used within the chip to generate the token and to generate the private public key pair, and the facilities that they have given by which the private key can never be exported is what makes it FIPS compliant. So, so the FIPS module, the TPM module does not have a USB interface. Since the token requires a USB interface, what we have done is we have added a secure controller. Secure controller is SLE78 from Infineon, and it's EAL6 plus certified. I think whole of India there are certifications EAL4 plus or 4-ish, and this particular chip is EAL6 plus certified, which acts as an and this doesn't do any of our digital signature tokens at all. It only acts as a bridge between the USB, between the host and the FIPS certified controller. Okay. It incidentally also implements the FIDO2 compatibility, which is you have a single token in which you can do both signature, signing, authorizations, as well as authentication using FIPS. We have two models. So this is a broad overview of what the two modules are. You may have seen the small hardware being passed around. One is a USB token, which is a USB type A token, which is the one on the left, which I call module 1. And in that you have a TPM module, which is FIPS 140-2 certified, and SLE78, which is a secure controller, which simply acts as a interface to your host. And the TPM module runs on SPI, Serial Peripheral Interface, for those of you who may have forgotten the college days. And there is a chip select which goes from there. In FIPS standards, you also have, in FIDO, you also need a touch to verify a user being present. It kind of avoids malware authorizing things without some human being physically present. So there is a touch module which is present on the token. In the morning, we heard about digital signature is fundamental to the whole thing. It establishes identity, it ensures security. Absolutely correct. The CCA have been very helpful to us in guiding us, helping us in how we do things. Now, one of the things that is still lacking in the entire infrastructure of digital signature certificate is identity. Now, you have a token. The token is extremely secure. The digital signature is there, but he steals my token. What can I do? He has watched by typing my password, so he knows the key. So which means I am liable to everything that he might do. I'm not pointing to him, but I did. Okay. So now what we have done is, in the second model, we have combined the biometric with the TPM, which is FIPS compliant and FIPS 140-2 compliant module along with the biometric. Now, the moment I say biometric, a lot of people say, oh, that's taking away my private information and putting it in the cloud and dangerous. In this case, what we have selected is what is called as a SOC, a system on chip. This system on chip encrypts your fingerprint and stores it internally. Even via the interface, I cannot get any information about your fingerprint. It allows me to enroll the fingerprint and only authenticate whether the user's fingerprint matched with that and gives me a true or false. It also tells me which is the fingerprint. You can enroll about, like you do in your mobile, you enroll n number of fingerprints, 5, 10, and then it will tell me that it is authenticated, based on which I go and sign a document. So when you want to sign a document, all that I will do is, I will first authenticate the user before I go and sign. So it means if I allocate this to a minister, the minister cannot claim that, and only his fingerprints are enrolled in this. it cannot be given to a secretary for signing. He has to put his fingerprint on this, which means there is absolute non-repudiation to ensure that he is held liable because he has put his fingerprint when doing the signature. So that is the level of complexity we are going into. I must warn you that these are all not certified. We are still in discussions. There are hundreds of questions that come to me. I try to answer them. We work with the CCA to bridge all the gaps that they find in our tokens, and we try to bridge it. We try to get it to an approved state as soon as possible so that there will be a homemade Atmanirbhar hardware token available. Now,
can I ask one question?
Please go.
Go back to your previous slide. So in this case, both are the secure controllers. DPM is also a secure hardware.
Sorry.
DPM is also a secure hardware. Secure controller is also a secure system. So where we are generating these keys and storing these keys? Both have the crypto accelerator.
Yeah, absolutely. I was fighting with the CCA for almost a year. I didn't succeed, so I went in for the second one. It is both. They are both secure, but from a regulatory perspective, only the TPM is FIPS 140-2 certified, and hence all crypto operations happen only in the FIPS certified TPM module. The secure controller, which also has a lot of other things, which if you ask me, that's also secure, but it is not compliant to the standards as laid down, and that's the reason why we have gone in for a separate TPM certified module. And that module, along with the particular version of the firmware, Mr. Pandian was pointing out that it's not just the hardware which is important, the firmware as well, which is the firmware 16 of that module is what is FIPS certified, and we'll be using that, and we will not do any changes to the firmware on the TPM module. The TPM module remains 100% same. We just send commands to it and get it back. So that is 100% certified, and we just send commands. The command will be sent from the secure controller, and what we try to do is we try to establish security around the whole thing by ensuring that there is a secure channel established between your server or driver or whatever you're using till that particular chip. Because of the fact that it is a secure controller, it is EAL6+ certified controller, we have good assurance of secure communication till that end. Like go to WhatsApp, it says end-to-end encrypted. So even though it goes through the internet and goes through multiple switches and whatnot, it is still encrypted between the token and the partner. The partner may be the PKCS11 driver, the partner may be a server, doesn't matter. It is encrypted between the partner and the secure controller, and the communication between the secure controller SLE78 and TPM itself is secured, and TPM is certified to FIPS 140-2. That's how.
In this case, what will be the boundary of FIPS?
It's just the TPM. It's only the TPM.
Then it is not need for certification of this device.
We will not go in for certification of the entire token once again. We will go in for CCA regulatory approval in order to use this FIPS certified. All the correct. So CCA have put guidelines and said this, if you do FIPS 140-2 module, you're okay. These things, no, you're not okay. You should do A, B, C, D, and the empaneled auditor will test that in our device to verify that we do all those things that CCA's guideline says we want. And if you do all that, they will certify it, and then it will go to the CCA for their concurrence.
So key storage of all these things happening in TPM?
Inside the TPM, yes, absolutely. Nothing comes out, other than the public key, nothing else comes out of the TPM module. The TPM.
Using both secure controller and so price of it will go high. So
Yeah, we'll all pay a little bit more. My company, I'll become richer. No, I'm just joking. Basically, the TPM module does not have a USB interface. So we have to put a USB interface. The USB to SPI controller, just the bridge, if you put a USB to SPI bridge, it will cost almost as much as the secure controller. Naturally, we have to develop a lot of firmware, but everything is in our control. It's a EAL6+ certified controller, so we took the option of ensuring that the security is paramount, and we have, instead of going in for a FTDI USB to SPI chip, we have gone in for a SLE controller. Okay.
My question is why you are using biometrics in a separate USB, type C or A? Why not you are using biometrics as a key component of the, like a public key in the certificates itself, in certificates itself?
So,
Because certificate has multiple variants. You can say the certificate has subject identifier, public key, private key, etc. One of the key field you may choose as a biometrics content, and where you can put hash of the biometrics in the certificates, as soon as when you compare your biometrics fingerprint through device or your token, that hash will recalculate from the stored hash in the certificate itself.
I'm not sure that I understand your question, but if you're talking about adding an attribute
Like
as
a
to,
public key is
we can add an attribute saying this particular document was signed using this fingerprint on the biometric, on the certificate.
Point is missing, that you have told earlier that certificate is being used, private key usage based on the PIN or password, where your biometrics contents is missing, because anyone can take your token, they can use by
Yes,
knowing your
yes.
PIN or password.
Yes.
Only thing is, once you are integrating your biometric fingerprint, it will make full proof of the certificate usage, this DSC usage.
Yeah.
So why not we are using fingerprint hash, our fingerprint hash in the certificate as a part?
We will consider that, sir. Thanks
Because
for your input. We
then
will consider
it
that.
eliminate the storing the fingerprint separately on any SIM or any USB, so that at the time of validation or authentication, one PIN is required, another your fingerprint is required to validate through your stored in the digital signatures part.
I understand the proposal, and I think it's very valid.
Because
We will
it
consider
is
that.
more easier that, because no man can use without their fingerprint digital signatures.
So, if I enroll, let's say 4 fingerprints, then I can take the content of the 4 fingerprints, include it in my certificate hash. That is something we can consider, sir. So, what I'll do now is I'll try to do a quick demo of this. I'm never good at demos, and for me, demos never work. Let me see. Oops, sorry. Is there any connection that I can get to the internet on this? Doesn't seem to connect to mine. Is there an internet connection available? It's come up. My phone has come up, so let me try that. Good. Naturally, it's going to be a little slow because using on my mobile phone. Yeah. So this particular product is called Innate Key, and Innate is something, a brand name that we have. Innate is something that's inherent to you. We just changed IT there to mean, instead of IN and ATE, we put IT there. So basically now it's asking me to log into a site with the fingerprint. All that I did was I inserted the device, put my fingerprint, and it has logged me into that device. Okay. Now what did it do? There is a whole lot of PK involved. I'll not go into the technical aspects because I was mainly focused on presenting the hardware token to you. The intent is not to explain the architecture of mine, but this also uses PKI, and this is our preferred way of applications logging in. We were talking about applications logging in. The application today, just now, logged in with no password from me, just with my fingerprint which I had enrolled and earlier registered. It knows who I am and it's taking me there. This is the ideal, in my opinion, a way in which an application can log in with all this. And we also work with banks, etc., to do this. Now, all that I want to kind of demonstrate is, if it all works, is a document sign. This is not part of our product. There's something that we have developed. It's test, prototype, still. All that we do is, instead of, we still not develop, we will be developing a PKCS11 driver for this and supplying it to the CEAs, and they will integrate it into their tool set for digital signing and all that. So we are the hardware manufacturers of the token, and we assist in writing the drivers to store the ask the token to create the keypad. Token will create the keypad, and the certificates will be stored there. We can ask it to sign. We write the drivers as well as do the manufacturing of the hardware. This is just a simple demonstration of how we can. So this is a particular sample document that I have taken, and I select the location where I am. I'll still say I'm Chennai, so it's already there. And then if I want to place a signature, you say click on signature, something comes up. And let's say I put my signature here. Once I put that, and I say sign with the TPM module. So all this will change, sign with digital signature. So when I sign with the TPM, it says give me the credential. I can have more than one credential. I select the credential and type the password and ask it to sign. It's signed, and I download the file. I download the signed file, and that's number 7. So I've been trying hard to ensure that it works today. 6 times I've tried earlier. Let's see whether this one works. Okay, that's me. So basically what it did was it went into the, it took the hash of the PDF, sent it to the token, got the token signed, came here, added it to the PDF, and that's what you see here. Now if I click on the certificate in this part, it says show me the signature properties. It tells you all the signatures valid, shows signer certificate. This is the 4 levels that people were talking about. So this is a certificate that has been issued by the test environment of eMudra. So we are working with CEAs in order to do this. So eMudra testing environment. So that's what has certified this. And for testing, I've used my colleague's name, Jagannathan, whose certificates were put inside this device, and eMudra, sub-CA, CA, and going to the root CCA. So this is the way in which you can store the sign a document digitally, and we also have a customer can have in his place get the certificate issued directly using the browser onto his token. So we are trying to generate a Atmanirbhar token so that we all have control over everything that we are doing, and rest of it we are working closely with the CCA to get necessary acceptance. Any questions?
Yeah, one more.
Thank you.
When you are signing this PDF, you have clicked the sign with TPM.
Signed with TPM. Yeah.
There are another link was there, signed PDF. There is a difference between these two?
No, basically we have, I mean, I should have hit that. It was not meant for this. The secure controller also has a facility to sign. So we have 2 products, actually one with the TPM, one without the TPM. If you don't want digital signature which is legally binding, I can sign with the secure controller. If you want a one which is legally binding, I have to get the token certified by CCA, certificate issued by a CA, then you can get a digitally valid, I mean, valid in a court of law is what is the digitally signed TPM. The other one is not valid in the court of law, but if you are willing to take the technical aspects of it, I can sign.
So in that case, both controllers are having the sign?
They have the signing capabilities. One is EAL 6+ certified, one is FIPS 140-2 certified. If you do a strict comparison, the older versions of the FIPS 140-2 said EAL 2 plus or 3 is equivalent to FIPS 140-2. Now, latest things don't say anything about it. So this is EAL 6 plus certificate. So this should be better, but it is not complying to the Indian standards. So that's the reason why we use the.
Are you using any WebSocket-based PKI component for signing?
This particular thing is a simple demo. So here we do use, we don't use WebSocket, we use a server-side event, SSE, to communicate, to have events set across in an encrypted channel.
Okay. But in the practical case, token.
Practical case, we will provide a PKCS11 driver to the user and they can use it. Now, we are also attempting to see whether over a period of time, the signatures can happen using a browser. So these tokens, we have also not just copied whatever was there Chinese, we have done it in such a manner that it is possible to communicate via a USB HID supporting browser, which is Chrome and Edge, both support. So 2 or 3 browsers support USB HID, and you will be able to communicate without installing a driver. So in my laptop, there's no driver installed and I can sign everything, but that is a matter which is subject to more audits, more questions, more answers, but we will get there.
So it's types of browser extension, or you will use the.
No, it is built into the browser. It's built into the browser. The browser, you know something called WebAuthn? So that allows you to communicate via the OS allows you to communicate with the token seamlessly, securely for FIDO and WebAuthn. The same method is what we are using to piggyback and send messages to the token. So basically, when you have a driver, what does the driver do? Your browser talks to the driver, driver talks to the device. The driver is the only mechanism which was available earlier to talk to the token. Now we can talk from the browser. Whether it is acceptable to the CCA, CEAs, that's all subject to discussions. Nothing is.
Actually, token has to be compliant as a CCID compliant. So in that case,
it is HID compliant.
CCID, USB CCID compliant. In that case, you require a driver, local WebSocket, or
No,
browser extension.
I'm
In case of HID, which FIDO talks about, in that case, HID, because browser support HID interfaces.
so this particular device supports HID.
But at current token in the market is all CCID compliant. It needs to be checked that what CC guideline says.
Yeah. So today there is no requirement. It just so happens that all the border sharing countries chips, decide to use that particular model. We have gone the other way so that it allows you to do a browser to device communication on all different OSs. You don't have to have any driver at all. You can go to Linux, Mac, Android, iOS, talk to the device. So to allow that, we have gone in that. There is no specification saying it should be this type of HID or no. So we have a CTAP 2.
It needs to be some.
It is just like you have not installed Acrobat reader, and still browser is opening our PDF file. In the same manner, your driver is working through browser.
So
it is required to
always
install at client.
Yeah. So today the driver is installed in the client. If you install the driver in the client, it will continue to work exactly the way it has been doing so far, and that is what we will definitely support.
Yeah.
We are just pointing out that it is also possible in the future if things change and CCA are willing to approve, there is a demand and it's deemed as secure, that you can send a message from the server via the browser and talk to the device. Because the security of the FIPS part is in the TPM module, which is also sitting behind the secure controller. The PKCS11 module, which is the driver, itself is not FIPS certified. It's only a mechanism by which the commands are sent to the token. So the browser can also send, provided there is secure communication established between the token and the source, which may be the server or the host itself. So these are subject to technical clarifications and people getting convinced that it will work and it's secure. We are in the process of doing that. But today we will give a PKCS11 driver so everybody is happy. And then if the next step of innovation comes in and people permit us to do that, we will establish that the communication between the server and the token is 100% secure. That's a secure controller, EAL6 plus certified, doing all these things for you, generating a random number, challenging, doing PKI between the server and this, all that we have done. It's just a matter of explaining this to people, getting their confidence, having it tested, certified by an independent lab. These are pending.
But for your token, once you plug token in the system, it will automatically get installed, or it will ask the driver to install.
That today we don't,
Because as soon as
but
new
it can,
driver-
the
new-
CA will work with it to automatically install the driver. So we give the PKCS11 driver to the CAs, CAs bundle it along with their product. Whatever the current mechanism that they adopt, I would expect them to adopt the same thing. Today is the first day, everything worked fine. Thank you very much.